And I'm doing this to see if Tesla's autopilot can be tricked, because it famously only relies on simple cameras to navigate the world.
Former NASA engineer and YouTuber Mark Rober has just released a viral video testing Tesla's autopilot, and the results are shocking. Out of 6 real-world tests, Tesla has failed 4. He has gone further and pitted it against a Lidar-equipped Lexus.
My Tesla on autopilot, however, only relies on simple cameras and its image processing to navigate the world. So to see if that tech is just too simple, we came up with a 6-part LiDAR versus camera head-to-head face-off.
These tests have revealed something that even Mark didn't expect to unravel. Tesla's self-driving technology has significant shortcomings.
My Tesla on autopilot, however, only relies on simple cameras and its image processing.
Let's unpack everything.
Now, with the car with the LiDAR, first test is just kids standing in the road. Not sure why he's doing that, it's very unsafe.
For the first test, Mark places a mannequin right in the middle of the road to determine whether the cars will detect it and stop in time. As expected, both vehicles actually pass this one.
The LiDAR would have to detect the kid and then slam on the brakes at least 60 feet in front of him. And it turned out, that's all it needed. As you can see here on autopilot, it actually stopped.
This brings us to the first question. Why start with this test? The thing is, self-driving systems are meant to spot obstacles, just like our eyes and brains do, and help prevent accidents before they happen. Now, Elon Musk has always said Tesla doesn't need LiDAR. According to him, this technology is too expensive and not really needed.
And in cars, it's friggin' stupid. It's expensive and unnecessary, and as Andre was saying, once you solve vision, it's worthless.
He perceives the use of LiDAR as counterproductive, since his vision is to make self-driving technology cheaper so more people can use it. So, what if his approach to make these cars cheaper is actually making them less safe? Musk goes further and argues that humans don't have laser beams to guide them while driving, and therefore, cars should not need them either. He explains that just a camera and smart AI should be enough to help attain this objective.
The entire road network is designed for passive optical, essentially vision. So in order to make a car drive properly, you have to solve vision. And at the point at which you solve vision, you really don't need any other instrument.
But here's the issue. We don't rely only on our eyes when driving. Our brains are constantly processing depth, motion, and context in real time. So expecting a car to do the same thing with just a camera and AI is not really realistic. Before moving on, we need to understand how the LiDAR system fixes this issue. Basically, it uses lasers that fire thousands of beams every second to create a detailed 3D map of everything around the car.
Basically, it's like having a bunch of laser pointers inside this shell, shooting all around the room. And each time you fire one of them, you then see how long it takes for you to see it hit the object it's pointed at. And since we know the speed of light, if we measure that time, it will tell us how far away the object is.
Cameras, on the other hand, only see in 2D, which makes it harder to judge depth, movement, and context. Sure, AI can help recognize shapes and objects, but it still relies on complicated software. And unlike LiDAR, cameras can miss things or have blind spots. And now, let us move on to the next test that Rober conducted. Rober went on to subject the 2 vehicles to a test involving the sudden appearance of an object on the road. In this case, he used a dummy in place of a kid running into the middle of the road.
We will now simulate the kid dashing out from behind a parked car using some clever engineering, giving the cars less than a second to identify the mannequin and stop themselves. Here we go, getting up to speed.
Both cars managed to brake upon detecting the sudden movement on the road. However, the Tesla stopped much later than the Lexus. The reason for this? Tesla's systems depends on AI to interpret what it sees. Therefore, it is possible that it might have spotted the movement a bit late, or it was still processing what to do. In this test, Rober simulated foggy road conditions by setting up several fog machines. He then placed the mannequin right into the fog. The Lexus passed the test with flying colors.
Here we go. Oh, wall of fog. So we plunge through the fog, coming to a very sudden brake. Hey!
However, the case was different when it came to Tesla.
I mean, slow-mo does make everything look sort of cool, but that wasn't the only shot. I actually hit the brakes there. That was on autopilot. The cameras didn't even hit the brakes at all.
This test led to a conclusion that the Tesla cameras might also be as helpless as your vision when driving in foggy conditions. Stick around to see what Rober's test revealed. And don't forget to subscribe to the channel and leave a comment with your thoughts. For this test, Rober simulated heavy rain on the road by using water jets. The goal was simple: see if both cars could spot the mannequin in heavy rain and stop in time. The Lexus handled it just fine and braked safely.
Okay, here we go. And as the wall of water started, Lidar seemed to not slow down at all. Oh boy. Until the last possible second. Another W.
But Tesla? It didn't stop at all.
Oh boy. Oh boy. And sadly, it did not.
As we have already mentioned, Tesla relies on a camera to navigate. So what happens when a camera gets wet? It blurs. And when rain keeps hitting the lens, it creates motion blur, which the AI might mistake for actual movement. On the other hand, Lidar does not operate like a camera. Instead, it uses laser beams to detect what's there, making it easy for it to detect objects even in torrential downpour.
Where we had 6 of the brightest lights that money could buy simulate either sunset or sunrise, or a truck in the road having its bright lights on.
In this test, Mark Rober wanted to find out if these cars could handle intense glare, as might be the case with the sun or bright headlights from other cars on the road. The idea was simple: see if the cars could still spot a mannequin on the road despite the blinding light. Put simply, it was all about how well they performed when visibility takes a serious hit. If you thought the Lexus braked in time, you're right.
The lights turned on. Oh, that's a bright light. Question remained if it would see the kid. Oh, come on, Lidar. Oh! And it did it, no problem.
How about the Tesla?
I really doubted that the Tesla could either. But when it pulled to a stop, okay, we stopped for the kid with the bright light. A W for the Tesla. And that.
However, as was the case with the sudden movement test, the Tesla stopped much later than the Lexus. This goes to show that despite the camera technology working just fine, it was not as accurate as the LiDAR technology on the Lexus. Alright, we know LiDAR can handle fog, rain, and even glare, but what about something more solid, like a wall? Can it spot that just as easily? Mark Rober subjected the cars to this test, and the results were shocking.
Lidar is perfect, and Tesla is 3 for 5, but as far as I'm concerned at this point, this one's the only one that matters.
For this one, Rober used a Wile E. Coyote-style painted wall to test the cars. He created a fake tunnel illusion on a solid wall. The goal? See if both cars could recognize it's not a real thing and stop before crashing. The results were shocking. The Lexus accurately detected the barrier and braked just in time before smashing into it.
Lidar, it isn't looking at what image is printed on the wall, so this sort of just looks like a wall, which would make this the easiest test of the day. And as I suspected, handled it with no problem. So
the Lidar system picked up the wall right away since its lasers bounced back, signaling the car to stop just in time. However, we would not say the same for the Tesla.
Detect it in time to step on the brakes, and it turned out... Holy me!
Now, Mark Rober's video exposing Tesla's self-driving flaws has sparked major debate. While many have given him credit for raising safety concerns, others accused him of trying to damage Tesla's reputation